A pleasant day, everyone. I am Jaysel T, Deliverio, and I will be discussing polygons and different types of polygons. So let us define what is polygon. So in geometry, a polygon can be defined as a flat or plane, two-dimensional closed shape bounded with straight sides. So a polygon doesn't have curved sides and not an open shape. So if a shape has a curved side or an open shape, then it is not considered as a polygon. And according to Morales Ana 2022, a polygon is a closed two-dimensional figure composed of straight line segments that meet at their endpoints. The line segments of polygons are called sides, and each endpoint is called a vertex. Polygons have at least 3 sides and 3 angles, and their sides must be straight. So based on these figures, we can determine the sides. So again, these straight lines that you can see, all that lines are called sides, and these are their endpoints, which we call vertex. And in polygon, there are 2 categories of it. These are the simple and complex polygons. A simple polygon is a polygon that does not intersect itself. In other words, its sides do not cross over each other and it forms a single closed shape. So in complex polygon, a complex polygon, also known as a self-intersecting polygon, has at least one pair of sides that intersect. This means that some parts of the polygon may cross over others. So to make it easier to understand what is the difference between simple and complex polygon, simple polygon, its sides or angles do not intersect with each other. While the complex, from the word complex, it is difficult, and its angles and sides intersect with each other. So examples include triangle, square, and pentagon. And its characteristics are each side connects to exactly 2 other sides, and the interior does not contain any points that belong to the exterior. While in the complex, it includes star-shaped polygons. So its characteristics are some sides may intersect, creating regions both inside and outside the polygon. The interior can contain points that are also part of the exterior. So the simple polygon, the interior point belongs to the interior point, and the exterior point belongs to the exterior point. While in complex polygon, the interior point can be moved or belong to exterior point, while the exterior point can be moved to the interior point. So I have here an example of simple and complex polygon. So again, simple polygon, its sides do not intersect with each other. So we cannot see a sides that intersects with each other. And here in complex polygon, its sides intersect with one another, just like here. So in polygon, we also have regular and irregular polygons. Well, the regular polygon is a polygon that has all sides and angles equal. These polygons are highly symmetrical and can be both convex or concave. The examples include equilateral triangle, in which all 3 sides and angles are equal. Square, all 4 sides are equal, and all angles are right angles. And the last one for my example is a regular pentagon. All 5 angles and sides are equal. So regular polygon is a geometric figure where all sides are of equal length and all interior angles are equal, and it is symmetrical with equal angles and sides evenly distributed around a central point. So irregular polygons. An irregular polygon is a polygon that does not have all sides and angles equal. These polygons can take on a variety of shapes and configurations. Examples are scalene triangle, rectangle, and irregular hexagon. In scalene triangle, all sides and angles are different. And rectangle, opposite sides are equal, but adjacent sides are not necessarily equal. The last one is the irregular hexagon. Sides and angles vary. So it is simply that regular polygon, its sides and angles are equal, and in irregular polygons, its sides and angles are not equal. So here are some examples of regular and irregular polygon. Again, we can conclude that all sides of these shapes are equal, and while from these shapes, its sides are not equal. So it is an irregular polygon. So I have here an examples of regular polygon. Let us start with equilateral triangle, as I have mentioned that polygon consists of at least 3 sides. So equilateral triangle, it has 3 sides of 3 number of sides and vertices, 3 number of angles, 60-degree interior angles, 3 lines of symmetry, 3 rotational symmetry. Rotational symmetry means the capacity of a shape to be rotated, and 0 number of diagonals. The next one is square, or what we all know as quadrilateral. So it has 4 sides and vertices, 4 angles, 90 degree, 4 lines of symmetry, 4 rotational symmetry, and 2 diagonals. And the fifth one is the pentagon. Pentagon consists of 5 sides and vertices, 5 number of angles, 108 interior angles, 5 lines of symmetry, 5 rotational symmetry, and 5 number of diagonals. So hexagon, we all know that it consists of 6 sides and 6 angles. So the next one is the heptagon, and the heptagon consists of 7 sides and 7 vertices, 7 number of angles, 128.6 degree interior angles, 7 lines of symmetry, 7 rational symmetry, and 14 number of diagonals. And the next one is the octagon. Of course, the next number of 7 is 8. So octagon consists of 8 sides and vertices, 8 number of angles, 135 degree interior angles, 8 lines of symmetry, 8 rational symmetry, and 20 number of diagonals. So the next one is the nonagon, which consists of 9 sides and vertices, 9 number of angles, 140 degree interior angle, 9 lines of symmetry, 9 rational symmetry, and 27 number of diagonals. And the last one for this chart is the decagon. Decagon consists of 10 sides and vertices, 10 number of angles, 144 degree interior angle, 10 lines of symmetry, 10 rational symmetry, and 35 number of diagonals. Although the chart ends here at decagon, but there is a continuation of that, in which it is also included the decagon, which consists of 12 sides, pentadecagon, 15 sides, icosagon, 20 sides, and hectagon, which has 100 sides. You must be wondering what is diagonal in polygon. So n is the number of sides, and the formula of getting the diagonal is d is equal to n multiplied by n minus 3 over all over 2 rather. So let us compute the diagonal of square, as the equilateral triangle has a 0. So square, the n or number of sides of square is 4. So 4 multiplied by 4 subtracted by 3 all over 2, we get the number of diagonal of 2. And the pentagon, d is equal to 5 multiplied by 5 subtracted by 3 all over 2 is equal to 5. And here are the references. So that would be all for my report for the topic of polygons and different types of polygons. Again, this is Jaysel T. Deliverio. That's all. Thank you.